So
Right.
for us, design for test for key tech, I think design for test is core to what we do. Keeping your assay perhaps in like a planar orientation where you're doing testing so you can actually watch the assay go through its steps,
Yeah.
I think is pretty critical. But I think that's one that's pretty often overlooked, to be honest with you, where, if you jump to kind of integrating your assay onto one cartridge, for example, and you put it in your prototype and it's not working, how do you unscramble that egg, right?
Yeah.
To know what's not working appropriately.
Yeah. Yeah. I mean, it is really difficult to have the discipline to, when you first get let's say you get a end to end run on a new assay or new product, it's a really exciting moment. It's a milestone in every project that's trying to do that. But, the difference between doing that one time and doing it, 99.8% of the time, 998 out of 1,000 I mean, that's potentially years of development, depending on what the assay is. And, that is what scale is, right? If you run 1,000 assays and two of them, fail for unknown reasons, maybe that's okay. But, again, it comes back to what your strategy is or how accurate you're trying to be. And those problems, by their very nature, don't tend to crop up until you have whatever it is, the prototypes or the cartridges or the infrastructure in place to run 1,000 assays. And, it can be difficult to get that kind of information early on just because you don't have the infrastructure in place. But, if you're thinking about it and planning for it, it can be relatively, low pain.
Yeah, I mean, design for test in my mind initially is like, yeah, design an integrated cartridge that, or, automated platform that you can actually evaluate each step along the way. But I think the right way to do it and the way we typically approach it, right, is break up that assay into multiple steps, right? Run multiple tests on the subsystems, right?
Right, right, yeah. If we can, I mean, it's like you said, being able to literally look and see that cartridge, it seems like kind of a nice to have, but it really is almost critical that, if you're boiling fluid while you're running PCR, your instrument's not really going to detect that, and you're not going to know it until it ejects it and you see the burn marks on the cartridge and the weird, burnt fluid and corrosion. If you can see that happening in real time, you can figure out, did it happen on the first cycle or am I, building up thermal energy in my cartridge and it's happening on the 39th cycle? Being able to see that in real time can save you weeks, if not months of debugging or engineering effort.